Most animals survive by avoiding damage. This one survives by absorbing it. On the African savanna, speed decides who eats and who is eaten. Acceleration, impact, venom. Everything favors the organism that can end conflict quickly. The honey badger is built around a different equation. What if collapse can be delayed? What if the body does not prevent damage, but postpones the moment it becomes fatal? In most mammals, skin is a boundary. In the honey badger, skin is a buffer. Beneath the coarse black and white coat lies a dermal layer far thicker than expected for an animal of this mass. But thickness alone is not the advantage. The skin is loose, exceptionally loose. It shifts independently of the underlying muscle. When a predator bites, the hide stretches. When claws hook, the outer layer rotates. Teeth sink in, but they do not lock the body in place. The honey badger can twist inside its own skin and counterattack. In transparent CGI cross-section, the structure reveals itself. Dense collagen bundles layered irregularly. Fiber networks dispersing pressure laterally instead of allowing it to concentrate. Force enters, force spreads. Penetration depth reduces. Tissue tears, but structural failure is delayed. The system does not eliminate injury. It creates time. That time is a window, a narrow window of survival between impact and incapacitation. On the savanna, seconds are the difference between being consumed and walking away. The honey badger invests in those seconds. Pain still registers, nociceptors fire, signals travel. But behavior does not collapse at the first spike of agony. Neurological gating prioritizes motor output over withdrawal. Stress hormones surge. Muscle activation persists. The body does not ignore pain. It outpaces it. Again, the principle is not immunity, it is delay. The animal remains operational long enough to alter the outcome. Venom tests that system chemically. A cobra strikes. Its venom carries alpha neurotoxins engineered to bind tightly to nicotinic acetylcholine receptors at neuromuscular junctions. In most mammals, binding affinity is high. Toxins attach efficiently. Acetylcholine is blocked. Signal transmission halts. Paralysis unfolds rapidly. The honey badger shifts the geometry of that interaction. Comparative receptor analysis suggests subtle amino acid differences in the binding site reduce toxin affinity. The receptor remains fully functional for acetylcholine, but the toxin does not seat perfectly. Docking is incomplete. Binding strength is reduced. In CGI molecular simulation, the toxin attaches, but not with the same stability seen in more vulnerable species. Some receptors are blocked, others continue transmitting signals. Neuromuscular shutdown becomes partial instead of absolute. Venom still spreads. The honey badger may stagger, it may fall, but systemic collapse is not immediate. That delay opens another window, a biochemical window of survival. During those minutes, hepatic metabolism processes circulating toxins. Concentration drops. Respiration continues. Circulation persists. The system buys time, not indefinitely, just long enough. But survival is not only about nerves and venom. Injury invites infection. Open wounds invite bacteria. Carrion feeding exposes the bloodstream to pathogens most mammals avoid. Here again, the system does not prevent exposure. It controls aftermath. Inflammatory cascades activate quickly, but not chaotically. Immune cells localize response instead of triggering runaway systemic shock. Healing prioritizes closure and function over cosmetic restoration. Scar tissue forms dense and practical. Mobility returns even when symmetry does not. Damage becomes integrated into structure. The body does not demand perfection, it demands continuation. Most predators depend on speed to end confrontation. The honey badger depends on extending it. Its skeletal frame reflects that strategy. Broad shoulders, short, reinforced forelimb, long claws adapted for leverage rather than pursuit. Low center of gravity stabilizing close engagement. In X-ray overlay, the body appears compact and torque-oriented. If attacked, it closes distance. If bitten, it rotates. If pinned, it bites whatever is accessible. The goal is not dominance, it is continuity. Predators require efficient victories. The honey badger converts efficiency into friction, and friction is costly. Cost accumulates in muscle fatigue, in blood loss, in uncertainty. A lion calculating risk must weigh potential injury against uncertain reward. The honey badger raises that uncertainty, not through size, but through refusal to shut down. Listen to the sound of its claws in hardened soil. Dry earth fractures rhythmically. Burrows collapse under repeated mechanical stress. The forelimbs function like reinforced digging tools, transmitting force from shoulder to claw without delicate articulation. Prey that hides beneath ground loses protection. The honey badger does not need chase velocity. It dismantles structure. Bone cracks differently. Between its molars, there's a dry compression, not slicing, not tearing, crushing. Dietary flexibility is not a personality trait. It is mechanical capacity. Rodents, eggs, insects, carrion, reptiles, venomous snakes. If calories exist, they are processed. Specialists starve when conditions shift. Generalists endure. Energy intake remains consistent even when preferred prey disappears. Consistency reduces desperation. Desperation causes mistakes. The honey badger reduces the need for risky gambles. Confront a cobra again. The snake strikes. Venom enters. The honey badger recoils, but does not disengage beyond reach. Because distance favors the snake's reset. Time favors the organism with greater tolerance to systemic stress. Minutes later, motor control returns. The animal stands again, the window held. This is not absence of fear, it is recalculated risk. When the body is built to delay collapse, the threshold for engagement shifts. The honey badger does not seek conflict. It simply does not collapse when conflict arrives. Most species are optimized to avoid catastrophic injury. The honey badger is optimized to survive after it. Skin delays structural failure. Receptor geometry slows neurotoxic shutdown. Metabolism reduces venom concentration. Immune modulation limits infection spread. Muscle and bone withstand blunt force long enough to respond. Each system extends the window. None eliminate danger. Together, they widen the margin, and margins compound. On the savanna, everything runs on speed. Speed of pursuit, speed of retreat, speed of paralysis. The honey badger introduces resistance into that system. Resistance slows resolution. Resolution delayed becomes opportunity. Opportunity becomes survival. Its coloration is stark, black and white, not camouflage, contrast. An honest signal that engagement will not be brief. Predators learn. Conflict with this animal costs time, costs energy, costs certainty. Friction accumulates, and friction changes equations. The honey badger does not overpower the savanna, it disrupts its velocity. Where speed expects submission, it finds persistence. Where venom expects silence, it finds metabolism. Where teeth expect surrender, they find rotation. Most animals survive by minimizing contact. The honey badger survives by surviving contact. That difference is written into collagen density, into receptor architecture, into liver enzymes and immune regulation, into musculoskeletal leverage, into the simple refusal of systems to shut down immediately. Remaining operational is enough. Not because the world softens, but because friction forces it to slow. On a landscape driven by speed, the honey badger is the drag, the resistance, the organism that does not break the rules, but bends the timeline. And in that stretch of seconds, in that narrow window between injury and collapse, life continues. That is the design. That is the machine. And in a system obsessed with acceleration, sometimes survival belongs to what refuses to stop moving, even when everything says it should.